Hi guys, welcome to the next lesson on significant figures. Under the cross specifications of study in units 1 to 4, in your study design, you can see that you actually need to be able to evaluate scientific methods. And in this, as a sub-dot point, you need to be able to calculate units and numbers with significant figures. So that just means reporting your answer to the appropriate number of decimal places or the appropriate number of significant figures which is specified in the question. And that's determined by the amount of least numbers in a question. So this is a cross-study specifications, a skill that you need to be able to do from units 1 to 4. It's not specifically in the unit 3-4 study design, it's in the cross-study specifications. So you need to check those. So a couple of rules about significant figures. Every non-zero digit is significant. So for example, 3.78 and 294, they both contain 3 digits, therefore they contain 3 significant figures. They are non-zero digits, so any number 1 to 9 is counted as a significant digit. Every zero digit, or every zero which is in the middle of a reading, is significant. That's significant for every non-zero digit, and when zeros are placed in the middle, they are significant. For example, 10.514, that's got 5 significant figures. If the answer was 1.0514, it would also contain 5 significant figures. 1, 2, 3, 4, 5. In the case of a 0 to the right-hand side, that is when zeros are also significant. So for example, 31.20 has 4 significant figures. When you have zeros before a number begins, so if the number is less than 0, typically, that is when they are not significant, and they only show place values. So in the case of 0.05, 1 significant figure. In 0.009, we have 1 significant figure. However, there's a 0 following it. 0.03 over here, we get 2 significant figures, because any 0 is following a number is significant. In the case of scientific notation or powers, they can actually have a number of different significant figures or places. So we follow the number of decimal places that there are. So for example, 4.34 by 10 to the 5 in a scientific notation form, that has 3 significant figures. If you were to expand that expression, it will be 4, 3, 4, and then 5 places on top of that. So then that would change the number of significant figures. In the case of 4.340 by 10 to the 5, in its scientific notation form, it has 4 significant figures. So what I'd like you to do now is apply the rules that we've just seen in the previous slide to this table. I'd like you to calculate the number of significant figures for each of these numbers. So pause the video, calculate these now, and then we'll go through them shortly. Okay, so the first one here has 3 significant figures. That's according to rule 1, where all non-zero figures are significant. The second rule, you can see that any 0 between numbers counts as significant. We have 1, 2, 3, 4, 5 significant figures. In this case here, any zeros before a number indicate only place value, so therefore we have 2 significant figures. Here, similar rule again, 3 significant figures because the 0 following a number is significant. That's rule 3. Again, this is the combination of rule 1 and combination of rule 2. So this is 3 significant figures. Here, zeros between a number are significant. So we have 6 significant figures. In the case of scientific notation, it follows the number of decimal places that there are. So this one has 3 significant figures in its scientific notation form. And this one here has 4 significant figures. Now I'd like to go through multiplication and division of significant figures. So if you're multiplying or dividing a particular number in a question and it's asking you to report in significant figures, then you follow these principles we're going to explain now. So when you multiply a number, for example, let's say 3.664 by 41.2, you have the least number of significant figures will determine the accuracy of your answer. So that means we have 4 significant figures here, we have 3 significant figures, therefore our answer can only be to 3 significant figures and be accurate. We can't place it before because the least number of accuracy is 3 significant figures. The same goes for when we're dividing a number. We have 4 significant figures here because zeros between a number count as significant. we have two significant figures here, which means our answer can only be two significant figures. In the case of addition and subtraction, it's actually the decimal points that determine the accuracy of the answer. So for example, here we have two decimal places. Here we have one decimal place. So therefore our answer, when we add it together, can be accurate to one decimal place. It's different to a significant figure. In the case of subtraction or addition combined, we can see that we have three decimal places, two decimal places, one decimal place, so we can only answer to one decimal place. And this is, of course, significant because any number following 0 to the right-hand side is significant. So in this case, with this example here, let's consider this one. 4.57 times 0.554 multiplied by 20.5 minus 824. So you use BODMAS to complete this sum here. So you solve the brackets first, and then inside the brackets, and then you subtract that, or you multiply that number by this number, and that would get you this number here. The answer is 2.4 because the least number of decimal places that we have is 1. So we can only answer to one decimal place. In this number here, we've got 4.57, 0.0554, and 2.4. Because we're completing a multiplication, we're dealing with significant figures. So the number that we have, 2.4, has two significant figures, and that controls the accuracy of the answer, so therefore it's 0.61. This is a review of what we've gone through today, and it categorizes what numbers are significant. So 1 to 9 integers are always significant. 0 is significant when it's at the front of the number, is not true. When it's between non-zero digits, it's always significant. And at the end of a number, it does when there's no decimal point. Otherwise, when it contains a decimal point, it is significant. This is just another summary showing some more ways of calculating significant figures and giving you the appropriate number of digits that you need to report in. So you should be able to now divide and add numbers to calculate significant figures. So divide and multiply, and decimal places using addition and subtraction. So you should identify the number of significant figures in a collection of numbers, calculate significant figures with decimal places in multiplication or division for addition and subtraction reactions, and report significant figures with scientific notation. This is the page you should read in your textbook to review this. Thanks for watching.